Alright, today we're going to discuss the production of chlorine and sodium hydroxide by the electrolysis of sodium chloride. This is the chlor-alkali industry, and there's basically the same products made each time, but different processes, and with each process has its own sort of environmental implications. So we'll be exploring those in another video. But we're going to start with the first way, or the mercury cell, which we don't actually use much anymore, and we'll sort of see why later. In another video because of the environmental implications. But this is what it looks like, and it looks kind of scary initially. You don't have to be able to draw it, but what we'll do is we'll step through the chemistry right now and try and see what happens. So let's start with just the cathode. So our cathode here is actually not a solid electrode, it's actually flowing liquid mercury. So this is our cathode here, and it's flowing around here, and then it's cycled back around here. And so what happens at the cathode is the sodium ions, which come from our salt water, or sometimes called brine, that will be inside the salt water here. The sodium ions are going to be attracted to our cathode because it's negative. This is an electrolytic cell, so we're applying a voltage and making this the negative electrode. And so it will gain an electron, and what will happen is it will sort of mix together with the mercury. So you have two metals that have just sort of mixed together, and we call that sort of an amalgam. So how we write that is just sodium slash mercury. So over here, this Hg amalgam, you can just think of that as sodium atoms and mercury atoms mixed together. So they flow along into this other compartment here, and we'll take a look at that next. Let's look at the anode quickly. Our anode over here are made of carbon, and so what will happen here is the chloride ions in the salt water, they're going to be attracted because it's positive, and they will lose their electrons and form chlorine. So that chlorine can actually be extracted right then and there. So one of our products is chlorine, and that can be used in chemical sort of industries. So now if we look at what happens to the sodium mercury amalgam, it comes over here, and then there's a side reaction, and so that's what we highlight over here. So previously in chemistry, you know that sodium metal is reactive with water. So what will happen is sodium will react with water, and we know that that always produces sodium hydroxide and hydrogen gas. So hydrogen is one of the products of this, and sodium hydroxide is a product of this. And both of those can be used. Hydrogen, for example, could be used in the Haber process. Sodium hydroxide is a common chemical used in many processes. And then we have still the mercury is left unchanged. It's just we've removed the sodium from it, so now the mercury can be recycled back. So that's what happens overall in the mercury cell. You want to be able to tell what all of the reactions are, what it produces. So that one's not very good because it uses mercury. Another video will look a little bit more at that. But now we're going to look at two more or sort of subsequent methods. The one we use most now is membrane cell, but they have a same diagram. So here we have, well, let's start with the diaphragm here. Here we have a separator. Now the difference between these two cells is what they use as a separator. In the diaphragm cell, they would use asbestos, which you may have heard of before. It's actually something that can cause a lot of damage to people's lungs. So we don't use this one as much anymore. We've actually replaced it with a membrane instead. And this membrane is made of something called a fluoropolymer. And what that basically means is it's a repeating chain of a polymer that includes a fluorine molecule. And what that will allow us to do is actually be able to separate or sort of be selectively permeable to only the sodium atoms without having to use something that's dangerous to human health. So both of these have the same overall reaction. So what happens at the cathode, let's take a look here. Our cathode is right here. And what will happen is the water that we have in here is going to gain 2 electrons. And again, this is an electrolytic process. So the electrons are going into here. And what will happen is the water will be broken down into hydroxides and into hydrogen gas, which can be extracted. So again, the same products as before, just slightly different process. And then the anode reaction is the same as our mercury cell. So what will happen there, what will happen there is our chloride ions will be attracted to our positive anode, so they will lose their electrons and as a result form chlorine gas. So we have chlorine gas formed there, hydrogen gas formed there. Sodium is actually just a spectator ion in this entire process, so that's a little bit different. And since we've formed hydroxide, we now have a mixture of sodium hydroxide, and so that can be taken out and used basically to extract sodium hydroxide. So you add those 2 reactions together, and that's the overall reaction, which is the same as the mercury cell process. So just looking at some of the advantages, let's look at this sort of one by one of the membrane cell, or in other words, why it's replacing all the others. So the membrane that we use, which is a fluoropolymer, it only allows sodium ions to pass through, but the diaphragm, which was made of asbestos, would actually allow the chloride ions to pass through too. So it wasn't as selective, and as a result, you would actually have more contamination on your one side where you just wanted sodium hydroxide. You'd get a mixture of sodium hydroxide and more sodium chloride. So it's better to use the membrane, because then on the one side you don't have the mixture of sodium chloride with the hydroxide. That leads to resulting NaOH solution is pure because there's no contamination. There's no mercury used in this one, so we have no mercury or asbestos contamination. And we have it cheaper to construct, and it's cheaper to operate than the other ones.